Hello. In this lesson, we're going to be looking at two-dimensional shapes, the definitions of them, their names, and then how we calculate measurements corresponding with them, things like perimeters and areas and all things of that nature. So our first vocabulary word is polygon. It comes from the root words poly, meaning many, gon, is the root word for angle, and so it's figures that have many angles, and because it has many angles, it's going to have many sides. So that's where the root word comes from. A closed figure formed by a finite meaning countable, so it can't have infinite number sides. So a closed figure formed by a countable number of coplanar just meaning they're all in the same plane, segments called sides. Here's the properties. Uh, each sides that have a common endpoint cannot be on the same line. And then each side intersects exactly two other sides, but only does so at their endpoints. So the polygon is just a figure formed by straight line segments, is essentially the mathematical definition of it. The vertex of each angle is a vertex of the polygon. So if you look, this polygon has 1, 2, 3, 4, 5, 6 vertices. So it's going to be a six-sided polygon. A polygon is named by the letters of its vertices written in order of consecutive vertices. So this could be called polygon G, H, J, and it works its way around in clockwise fashion. You cannot jump around. Once you pick a starting point and then denote a direction, you have to continue until you get back to that side. What you are free to choose is you are free to choose where you'd like to start. So for example, you could start at K and then go counterclockwise. You could call this polygon K, J, H, G, M, L, and that would be legitimate. But you can't jump around. It has to go in the order that you started from in the beginning. Polygons come in two types of fashions when you're talking about their sides. They can either be concave meaning con meaning width, cave meaning cavity with like a dent. Concave are polygons that have caves in on one side. So this is a concave polygon because you can see one side is dented in. What they mean by that is if each side was straight, infinite lines, some lines would intersect. So yeah, some of the lines pass through the interior is what they mean. That would be a concave polygon. It's easier just to look and see if one side kind of dents in. That's really what's going on. The opposite of concave is called convex, and the definition of convex is it's not concave. So if there is no side that dents in, where the sides would pass through the interior if they were infinite lines, then you have a convex polygon. There's a special type of convex polygon when all sides are equal, and that's called a regular polygon. So a regular polygon is a convex. It has to be convex. There is no such thing as a regular polygon if the polygon is concave. It's a convex polygon that is both equilateral, meaning equal sides, and equal angular. If it's equal sides and equal angles and a convex polygon, it's a regular polygon. So this is regular pentagon because there's 5 sides and the prefix pent is 5. This is a regular 5-sided polygon called a regular pentagon. You can name polygons based on how many sides they have. Some of these root words you might recognize. Tri is a 3-sided polygon. We call it triangle. Quad is 4, so that's a quadrilateral. Pent is 5, so a pentagon is a 5-sided polygon. That's where after 4, they all end in gon. Hex is 6, so hexagon. Hept is 7. Oct is 8, non is 9, decagon is 10, like decade, 10 years in a decade. Then really, I've never heard of a hendecagon. You can just start saying 11 gon. Dodecagon I have heard before. Do is 2, dec is 10, so this is a 2 and a 10. That's a 12-sided figure. And then after that, they kind of stopped giving names. You could just say 13 gon, 14 gon, however many sides. Technically, you could probably do that for anything bigger than 10. So that's how we name polygons based on how many sides they have. So we're going to practice it. We're going to name each of the polygons by how many sides it has, and then classify it as either convex and concave or regular/irregular. So let's start by naming it by how many sides. This has 1, 2, 3, 4, 5, 6. So this is a hexagon. I would like to be able to write, not grab. There we go. This is a hexagon. What other things? Then it classified as convex or concave. There's no sides that dent in, so this is convex. And because all sides and all angles are equal, this is regular. No, this one, this is dented in, so that's definitely going to be a concave. How many sides does it have? 1, 2, 3, 4, 5. Hey, this is a hexagon as well. So it's a hexagon, same as the last one, but it is concave. If it's concave, there's no way it was ever going to be regular, but another reason it's not regular is it has all sides equal, but it doesn't have all angles equal. So that's why it is irregular. And then your job is to try the last one. So pause the video now for maybe, I don't know, 30 seconds. Unpause it once you've tried with the star. Welcome back. First thing, how many sides? It's 10-sided, right? There's 5 points. Each point has 2 sides, so it's 10-sided, a decagon. It is concave. There's dents on every single side. And then the last part is it is irregular because it is concave. Because it's concave, it has to be irregular. There's going to be multiple these angles right here are definitely going to be not the same as those angles. So that is why it is not regular. Now we're going to talk about measurements for two-dimensional shapes. One of the first ways you can measure is a perimeter, which is a measurement of the outside. It's the sum of the lengths of the sides. So if you added up all of the side lengths for a polygon, that would be its perimeter. The circumference is a special type of perimeter. It's the perimeter for a circle. So it's the distance around the edge of a circle. The area, so first these two measurements, perimeter and circumference, are one-dimensional because they're just lengths. Area is a two-dimensional measurement. It's a measurement of the number of square units that would be required to cover that surface. As I noted, perimeter has one-dimension units, so its units are units, centimeter, feet, miles, etc. Area is two-dimensional because it has a length and a width, so it's units squared, centimeters squared, feet squared, miles squared, all the way down. Your book provides you with the formulas for these, and I would write them down on your formula sheet that I either passed out in class or I supplied on the class website. A triangle's perimeter is you add up its sides, so B plus C plus D. The area of a triangle is 1/2 its base times its height. In a future lesson, we'll talk about where all these formulas came from. Right now, we're just practicing using them. So you're just going to be using them. You're just going to be given these formulas and you're practicing interpreting what each of the variables means and then using it. In a follow-up lesson, we'll talk about where these things come from. Area of a triangle is 1/2 base times height. Some of you might know already it's because a triangle is half of a rectangle. If you have a square, its perimeter is just s plus s plus s plus s because they're all equal sides, so you could just do 4 times s. The area of a square is s times s, well that's just s squared. A rectangle is a quadrilateral, so its area is going to be length times width. Its perimeter, well there's 2 lengths, and there's 2 widths. So 2 lengths plus 2 widths would be the perimeter of the rectangle. A circle, its circumference, which is the math term for it's the perimeter of a circle, its circumference is 2 pi times its radius. So pi is the constant 3.14159 ... going on forever. There is a button on the calculator I show you. The pi button is right here. Don't approximate it as 3.14 right now. So if you needed to, you would get second and then hit this button, be pi. 3.14 is the approximation. If you want to be exact, there's the button right there. If you absolutely cannot, you don't have a calculator that uses it, then use 3.14. But if you have a calculator that does it exactly, use that button. It's more precise. Another way, instead of doing 2 pi r, well, 2r is the radius. If you have 2 radii, that's just the diameter. So instead of saying 2 radii, you could just say diameter. So circumference could also be pi times diameter. We'll talk about where that comes from in a follow-up lesson. The area of a circle is pi times its radius squared. We'll also talk about where that comes from. You'll notice it has square units because it's area. Length times width will be square units because each of those are one-dimensional units. Square units, base and height will make square units. And then here's what each of the variables mean. It might be wise to write those down as well. So there's our formulas for two-dimensional shapes. Note for triangles, the height is always the perpendicular distance from the base to the highest point. Sometimes that height might occur outside the actual triangle. If you have a right triangle, the height will be this leg. This triangle right here, its height would be the perpendicular drop down distance from right there. So in yellow, I've highlighted the actual sides of the triangle. If you have an obtuse triangle where one of the angles is obtuse, then your height is actually going to be the distance from this tip all the way straight down. It is not this slanted distance. Height is perpendicular height. It's the altitude or elevation if you want to think about it. It's how high up the highest point is compared to the ground. That's what we mean by height for triangles, and actually all shapes. So practice using them. Imagine that you are going to be manufacturing the following figure and you need to print out just this red. What would the area of just the red be if the circle has a radius of 13? So our idea here is going to be, if I want just the red, we should find the area of the entire circle and then subtract out the rectangle. So that's going to be our theory. So the red will equal the entire circle minus the rectangle. Let's write down our formulas. The area of a circle is pi times its radius squared. The area of a rectangle is length times width. Now I fill in. Pi times the radius of the circle is 13. So that means the distance from here to there is 13. So pi times 13 squared minus, it doesn't matter which one you call length and width, it's just a matter of perspective. Say this is 24, and then this is 10, and then you just run the calculation. So I grab my calculator, pi times 13 squared, subtract 240, because that's what 24 times 10 will be. I get 290.93. In my units, it doesn't tell me, so I should just write units squared, or you could do u squared if you want to. But you need to include units. So if they told you this was feet, you'd say feet. If it was centimeters, you'd say centimeters. Whatever, millimeters, whatever it's being measured in. That's how you would do the first one. Second one, let's say a gardener is looking to fence in an area that is 36 square feet. What would be cheaper? Would it be cheaper to use a circular fencing strategy or to do a square fence? So let's see, both of these have areas that are equal to 36 feet squared. Now I need to figure out what their perimeters would be. How much fencing would it take? Let's do the square first. The area of a square is s squared, but I know its area is 36, and so I can find what each side of it must be if I take the square root. Each side is 6. If each side is 6, now I know the perimeter of the square. The perimeter of the square would be 4 times 6. It would take 24 feet of fencing to do it if I used a square. If I did a circle, area of a circle is pi r squared. Its area is 36 equals pi times r squared. So I need to solve for r. Divide by pi. Divide by pi. 36 divided by pi is 11.46. So 11.46 equals the radius squared. Take the square root to get the radius. So square root of 11.46 tells me the radius is 3.385. 3.385 is equal to the radius. Now I want the perimeter. Well, that's the circumference of a circle. The circumference of a circle is 2 pi times its radius, but its radius is 3.385 because I just found it. So 3.385 times, well, it's 2 pi times its radius, just to be super clear. 3.385. 21.27. So to enclose the same amount of area, I would only need 21.3 feet of fencing, while the square would take 24 feet of fencing. Based on that, which one would be the better choice? It would be better to use the circle because it would require less fencing. The circle is more efficient than the square. You might have guessed that before, but now we mathematically proved it. Last application question. Find the perimeter of the triangle shown below. So perimeter is just add up all the sides. One of these sides is pretty easy to do. I think this side right here is pretty easy to do. QR, we can just count. So QR would be equal to counting 1, 2, 3, 4, 5, 6, 7. QR is 7. Now I'm going to show two different methods for getting the slant ones. PQ, which one's PQ? Over here. Let's do that one first. For that one, I'm going to use the distance formula that we did in a prior lesson. So if I do the distance formula for PQ, I need to write what its coordinates are. P is -1, 3, and Q is -3, 1, and then I use the distance formula. The distance formula is the square root of, I'll write out what it was. It was x2 minus x1, how far apart are the x's, plus y2 minus y1, how far apart are the y's, and then I square. Then I just run that calculation. So there's the formula, now I run it. Square root, -3 plus 1 is -2, and -2 squared is 4. -3 minus 4 is -4, and -4 squared is 16. That will give me the square root of 20. That's an irrational number, so I'm going to have to approximate it using a calculator, and it's like 4.47. So PQ is 4.47. That's how I could use the distance formula for PQ. To get PR, the very last side, I'm going to do it by drawing in a right triangle. It's the exact same strategy as the distance formula, because the distance formula is based on the Pythagorean theorem, but it becomes more clear if I draw it in. So if I'm after PR, I'm going to draw in a right triangle and just count the sides. This is 1, 2, 3, 4, 5, so that's 5. This is 1, 2, 3, 4. Then I just do the Pythagorean theorem on it, because 5 squared plus 4 squared has to equal PR squared. 5 squared is 25, 4 squared is 16, that'll make 41. Then I take the square root of each side. Square root of 41 is also an irrational number, so I'll have to approximate it. 6.40 equals PR. Now I have all the side measurements, and then I just add them up. So the total perimeter, when I add up all the sides, would be 7 plus 4.47 plus 6.4, 17.87 units. I just use U for units. So you can either use the distance formula or just draw in a right triangle and then do the Pythagorean theorem. It's the exact same as the distance formula. You're just doing some of the computation in your head. I'm going to ask you to try, and then that'll be it for this lesson. So here's a shape we haven't really had a formula for. It's a hexagon, but the reason why is because you can split a hexagon into a bunch of equilateral triangles. So if I asked you to find the area of the following hexagon, I would say let's split it up into triangles, because we can find the area of triangles. It's 1/2 base times height. So what I'm going to do is I'm going to find the area of one of these triangles and then multiply it by 6. So I need the height though, because right now, let's see, all I know is that, well, if this is 5, then this is 5 and that's 5. Let's write that in so you can kind of see more. If this is 5, these are equilateral, that's 5, that's 5, all these are 5. If this is 5, I need the height of the triangle. I know that that's going to be 2.5, that's 5. How can I get the height? Well, it's a right triangle. And if it's a right triangle, you can use something we just used in the last example. So there's your hint. I'm going to pause the video now, see if you can figure it out for yourself. I'll maybe pause it until you've tried it, unpause it when you want to see it all the way worked out. Okay, answer you should get is 10.8. Let's see where that comes from. You have to do the Pythagorean theorem. If you want the height of that triangle, let's call this h. I know h squared plus 2.5 squared has to equal 5 squared. If I do the calculations, I'm going to save us a little bit of time and just do it right here, typing it on the calculator. I'm going to get that the height of that triangle is 4.33. So I can get the area of this yellow triangle by doing area of just that yellow triangle. Area of the yellow is 1/2. Its base is 5. Its height is 4.33. When I multiply 4.33 by 5 and then by 0.5, the area of that triangle should be 10.825. That would be the area of the yellow triangle. If I wanted then the whole hexagon, I would take this and multiply it by 6. But what would the original question say? In order to find the area of the regular hexagon, I want to find the area of one of these regular triangles and multiply it by 6. Find the area of the entire hexagon. So the entire would be 10.8 times 6. So the total would be 64.8 centimeters squared, because the area of just one of those triangles was 10.8 centimeters squared. So multiply by 6 because it's a hexagon. There's 6 triangles in there. That's it. Thank you very much. Have a good one.